So this lesson is going to be on graphs of polynomial functions. And we are going to work in this packet for at least 3 days, maybe 4 days. So this is going to be a long process of learning. We're just going to take a little bit at a time. A lot of the stuff we're going to do today is going to be calculator stuff, so make sure you have your graphing calculator ready. But a polynomial function can be written in this form where all these a sub n's are going to be real numbers, so no imaginary numbers there, and all of your exponents are going to be whole numbers. So like 0, 1, 2, 3, 4. So nothing weird, no fractions, no negative exponents. All right, and the degree of the polynomial is going to be the largest exponent. We talked about that before with polynomials, but today we're talking about a polynomial as a function. So a lot of the stuff is the same, but you might see a little bit of differences throughout the lesson. All right, so we have 6 different polynomial parent functions. A constant function is when the degree is 0, and it's just going to be something like f of x equals a number. So we're just going to put a to represent a number. All right, the parent linear function is f of x equals x. Quadratic is f of x equals x squared. It has a degree 2. 2 is the largest exponent. Here is degree 1. 1 is the largest exponent. Right, and then those are what those parent function graphs look like. A constant is going to be a horizontal line. The linear parent function is going to be a slanted line with a slope of 1. A quadratic function is going to be a parabola that goes through the origin. And then we have a cubic function. It's going to be, the parent function is f of x equals x cubed. And it looks like this shape. Well, this shape. Quartic looks a lot like the quadratic, but it's just kind of wider at the origin. So it hangs out at the origin a little bit longer than the quadratic. And it's a quartic, so it's f of x equals x to the 4th. And then the quintic looks a lot like the cubic parent function, but same thing. It hangs out at the origin a little bit longer. And it has a degree of 5, so the parent function is just f of x equals x to the 5th. Now, we aren't really going to graph a lot of parent functions. We are going to graph transformations of parent functions that they could have all kinds of little swoops and swirls in between. So they're just going to take those graphs and change them a little bit. All right, so one of the main things we're going to talk about today are turning points. And a turning point is when the polynomial function switches direction. So for example, we're going up and to the right, and all of a sudden we switch directions and start going down and to the right. That is a turning point. And if that turning point is higher than all the nearby points, it's called a relative maximum. So that's what this would be right here. All right, if that turning point is lower than all the nearby points, like this when we turned here, that's going to be a relative minimum. All right, now what I also tell my students when we do relative max and relative min, that a relative maximum is the top of a mountain. and the relative minimum is the bottom of a valley. So anytime in your problem you have a mountain or a valley, that is going to create a relative maximum and a relative minimum. Now this graph is going to keep on going up and up and up and down and down and down. So it's not going to be the absolute highest, but it's just higher than the points that are around it. All right, so relative maximum and minimum values are also called extrema. So if you see that word or hear that word, that's what you're talking about. Extremes of the graph are relative max and mins. Okay, now most of the time you need a graphing calculator to find the relative max and mins because they don't always occur like at a perfect point. Sometimes they occur at some decimal point. So we're going to follow these steps. So the first step is to graph the function. Enter that function into y equals and hit graph. So this is the function we're going to use, this one at the top. So I'm going to scroll down a little bit and over so I can see. All right, so I went ahead and I hit y equals already, and then I'm going to type that in. So we're going to do x to the third. Now make sure every time you use that little caret button or rooftop button to get to the third, to come down from the exponent, you have to hit the right arrow. And then minus 6x squared. The squared button is a little bit faster to use the button that's right above the log button. Okay. Then I'm going to just minimize this for a second. And then just hit the graph button. Oh, I need to change my window. If your window was something weird, you can always hit zoom 6 to change the window. All right, so everybody check their graph to make sure that it looks like that. All right, and then I am just going to do a little sketch over here on the side. Maybe. There we go. Okay, so it looks something like that. Okay. Then we're going to use the calc menu to find the maximum and the minimum. And they didn't really give a lot of directions on that, but we'll write them in. So that means you're going to hit second, and then you're going to hit the trace button. Because above that it says calc. And when you do that, you get several options. And so one of the words will be minimum, one of the words will be maximum. So if you're looking for a maximum, you choose that one. If you're looking for a minimum, you choose that one. All right, so let me show you what I'm talking about. So it's second and then trace. Let's start off and find that maximum. It's on the left. We'll work from left to right. So then we're going to hit the number 4 for maximum. Right, so what pops up is this little flashing cursor. Normally it starts on the y-axis until we move it somewhere else, but we are going to hit, we're going to move that flash, we're going to keep that flashing cursor where it is right now. We want to hit enter on the left side of the maximum. Our maximum is here. It's flashing on the left side, so we're going to hit enter. And then we're going to use the right arrow, move over to the right side, and hit enter. And then hit enter one more time. So enter on the left, move over to the right, hit enter, and then enter one more time. And then these numbers down here is the ordered pair. That's your maximum value. So we're just going to round to 2 decimal places. All right, and then we're going to do something very, very similar to find the minimum. All right, and step 3 I kind of talked about, but there it words it, or you can read that. All right, for the minimum, we're going to do second, trace. This time we're going to choose number 3. All right, so it's flashing where my maximum is. I'm going to move closer to the minimum, but I'm going to stay on the left side. So here's the minimum. This is the left side. This is the right side. So I'm going to hit enter on the left. Then I'm going to hit the right arrow, go down the valley, start going back up, and hit enter on the right, and then hit enter one more time. All right. So this is going to be the order pair for your answer. All right, so again, I'm just going to round to 2 decimal places. All right, that's what we're doing today. We're also going to throw in some domain and range in there too. All right, so let's look at number 1. Number 1, we're going to go in to y equals, and we're going to type in the function for number 1. Okay, and this is what the graph should look like. Now this time I'm not going to just do a little graph, we're actually going to graph actual points. And so the first points I'm going to graph are going to be my maximum and my minimum. So my maximum is here. To do the graph, I'm going to hit second, trace, and I'm going to find the maximum first. So I'm going to choose number 4. All right, so right now it's right on top of it. So I want to hit enter on the left side of it. Hit the right arrow, go up over the mountain, start going back down. Hit enter on the right side, and then enter one more time. Okay, now this comes up quite a bit. It can be somewhat annoying, but this E -6, you might have got E -7 or -8 or -9, -12, or your calculator may have given you 0. It's just something in the algorithm of the calculator. But anytime you see this E with a negative, some negative value, that just means 0. It means -0.0000001454. So that is the same as 0. So that's going to be our maximum is at 0, -3. So let's go ahead and graph that point, 0, -3. So I went to 0, 0, and I don't go over any, I go down 3, and there's my point. All right, let's go back and find the minimum. So the minimum is here. We're going to hit second, trace, and we're going to choose number 3. So we get this flashing cursor. We're going to move closer to the minimum, but stay on the left side and hit enter. Hit the right arrow. We're going to go down the valley, start going back up, hit enter. So you might notice you get these 2 little arrows pointing towards each other. Your calculator is checking for the lowest value between those 2 arrows, and they need to definitely be pointing towards each other and not away from each other. All right, this one's great. We don't have to round. So the minimum, the relative minimum, is at the point 2, -7. Okay, so I'm going to plot that point. So from 0, 0, I'm going to go right 2, down 7. Okay. Now I'm gonna see if I can get a few other points. We'll see what the calculator will give us. We could graph it using that, but let's just go to the table. So that's second graph. All right, so I'm gonna put the negative 1, 7 in there. Is it negative 1, 7? It's negative 1, negative 7, sorry. Negative 1, negative 7. All right, 0, negative 3 I got. Let's go ahead and put 1, negative 5. And then 3, negative 3. All right, and then all the other points that are on this table end up being just way too big or small. They won't fit in our little graph. So this is a good enough graph. Right, just to remind you of what it looks like, it's like that. So I'm going to make that similar shape through the points. Now it's important that you get a good graph here because we're going to use this graph tomorrow and the next day to do other parts of this. Okay, now I'm just going to go ahead and tell you right now, the domain of every polynomial function is all real numbers. So you can just go ahead and put that R there, that fancy R that means all real numbers. Because they're all going to have an arrow pointing to the left and an arrow pointing to the right. So the domain is going to be all real numbers. Now the range will change from problem to problem. Now this one, because I have an arrow going down and I have an arrow going up, my range is also all real numbers. Okay, let's look at number 2. So let's go ahead and get that typed into the calculator. This one looks like a kind of a crooked W. So I hadn't talked about this yet, but this one is actually going to have 2 relative minimums and 1 relative maximum. So it's okay. You can have multiple. So anytime you have a valley, it creates a minimum. And anytime you have a mountain, it creates a maximum. Okay, so let's start on the left and figure out this minimum first. So second, trace, and then choose number 3. All right, so my flashing cursor is in the middle on the y-axis. I want to move it to the left side of this minimum. So I'm just going to keep hitting left until I'm on the left side of it. So I'm definitely on the left side. I'm going to hit enter. Then use the right arrow to move to the right side. Hit enter. And then enter one more time. Let me move this down. That gives us one of our minimums, and it's not a perfect number, so we're just going to go ahead and round to 2 decimal places. All right, and let me just double check. Okay, I'm going to go ahead and graph that. So negative 1.84 is between negative 1 and negative 2, so I would a little closer to negative 2. And then negative 3.3 is going to be a little lower than negative 3. So 1, 2, 3, and then just go a little lower than negative 3. All right, let's see what we want to find next. Okay, so now I'm just going to move from left to right and find that maximum. So second trace number 4. So I'm going to move closer. Oops, too close. I know for sure I'm on the left. I'm closer to it, but I'm on the left. So I'm going to hit enter and then hit the right arrow till we go over the mountain, start going back down. And I know for sure I'm on the right. Now I don't want to go right too far where I'm like going through another minimum. So I just make sure I move to the right side, hit enter. So my calculator is going to check for the highest point between those two arrows. All right, so I have this E -6 again. You guys might have an E -4, E -8, or E -12. Any of those mean 0. So the X is 0 and the Y is 5 on our maximum. So let's go ahead and graph the point 0, 5. All right, and then we have one more minimum to find. So it's second trace number 3. So I'm going to move close to it. I'm going to hit enter. I was on the left side. I was closer, but I was on the left. Now I'm going to move down the valley, start going back the other side till I'm on the right side. I'm going to hit enter and then enter one more time. And then I'm going to round to 2 decimal places. And I'll go ahead and graph that. So it's really close to the 0.13. It's a little bit on the other side of 1 and a little bit below 3. Okay. Now, I'm not going to find the other points on this one. I'm just going to take my maximum and 2 minimums, and I'm going to draw that kind of crooked W like it looks. And that's going to be good enough. Okay, so like I said before, the domain of every polynomial function, which is all we're talking about right now, is going to be all real numbers. And then, like I said before, the range changes from problem to problem. And so on this particular one, I do have a lowest minimum, a low. I have 2 relative minimums, but one of them is the absolute lowest, which is this one right here. So my range is going to be all the y's that are greater than or equal to that low point of negative 3.31. All right, so the next 3 graphs I have it graphed already on your paper, so we're not going to worry about doing that every time. But we still will have to type them in the calculator to find the relative max and minimums. Whoops, don't do it like I did it. Let me start over. Make sure, I said this at the beginning of the video, that you come down from that exponent. Okay, so it looks like the one I drew. Obviously, I didn't draw it perfectly, but it's close. So this one has 1 relative minimum and 1 relative maximum. So let's just start on the left and find the relative minimum. So there's my flashing cursor. I'm going to move so I know I'm on the left side of the minimum and hit enter, and then use the right arrow to move to the right side of the minimum and hit enter, and then enter one more time. All right, so both of these have this e -7, e -12. So that means that the x and the y on this minimum are both 0. So the minimum occurs at the point 0, 0. All right, let's check out the maximum. So second trace, number 4. I'm going to move closer to it and hit enter. Move up and back down and hit enter on the right side of it, and then enter one more time. So when this says maximum, it is the maximum, so that's good. And this one comes out with a perfect number. So the maximum here is the 0.24. All right. And then for the domain, your domain is going to be all real numbers because it's polynomial, and they all are. And then for your range, because I have an arrow going down and I have an arrow going up, my range is also all real numbers. Okay, so I want you guys to try a couple on your own, finding the relative max and the relative mins and the domain and range on number 4 and 5.